Hello, welcome to Learnwizz. It's me, Learnwizz. In this video, we'll be discussing a small topic and a very important and difficult topic for some of the students. Okay, so it's a most requested video. So our topic is electrochemical cell. It's from the chapter Reactivity Series and Electrochemistry from CBSE Chemistry. Okay, so let us make it easy. Come on. Okay. So what is an electrochemical cell? So electrochemical cell is a cell that converts what kind of, first of all, you guys should know what kind of energy transfer is taking place. Okay. So in this electrochemical cells, electrical energy is converted to chemical energy or chemical energy is converted to electrical energy. So what is happening? So when you hear the word electrochemical cell, okay, electrochemical cell, first you think about the main cell, galvanic cell. Okay, what do you think? You have to think about which cell? Galvanic cell. Okay, galvanic cell. And galvanic cell, you should know what is happening in galvanic cell. So galvanic cell, when you hear the word galvanic cell, you should remember what all reactions take place in the galvanic cell, etc., etc. So in galvanic cell, inside the cell, chemical reaction is taking place. Okay, and after that, electrical energy is produced. Okay, due to the chemical reactions taking place in this inside the cell, we will get electrical energy. That is happening in the case of galvanic cells. Okay, let us move on to the electrochemical cells. Okay, so what is the energy transfer in this electrochemical cell? That is the first thing we have to study when we study about electrochemical cells. Okay, so here in this case we have to, okay, so they are going to discuss about electrochemical cells. Okay, so first of all, you should know what type of energy transfer is taking place in an electrochemical cell. Okay, so when you hear the word electrochemical cell, the galvanic cell should be coming to your mind. Okay, okay, you should think about which cell? Galvanic cell. When you hear the word electrochemical cell, just you guys remember about galvanic cell. And in galvanic cell, what is the energy transfer taking place? So after studying the full galvanic cell, it will be clear for you, okay, which type of energy transfer. So you can come back which reaction is taking place. So first of all, you understand that in electrochemical cell, we are doing what? Chemical reaction. So here, chemical energy, okay, chemical energy will be converting to which energy? Electrical energy. Okay, that is the energy conversion taking place inside the galvanic cell or electrochemical cell. Okay, the best example for electrochemical cell is galvanic cell. Okay, so in galvanic cell, a common example we are taking is what? Daniel cell. Okay, Daniel cell, that is zinc copper cell. Okay, so in an electrochemical cell, there should be two half cells. So first of all, you should draw a two half cells. Okay, so in the left side, so this is the left side and this is the right side. In the left side, you have to take, so it is zinc copper cell. You have to take a zinc solution here, zinc sulfate solution I am taking here. Okay, and in this right side, which solution you have to take? Since it is zinc copper cell, you have to take copper sulfate solution. Okay, and in zinc sulfate solution, you have to dip zinc rod. Okay, which rod you have to dip? Zinc rod. In copper sulfate solution, you have to dip which rod? Copper rod. Okay, and after that, you have to connect this zinc electrode and this copper electrode to a voltmeter. Okay, voltmeter, you have to connect it. And also, you have to connect these two half cells by a U-shaped tube. Okay, So I will explain what is the use of this U shape too. Okay, what is it called as? I'm just giving a U shape to connect these two half cells. Okay, so this is the diagrammatic representation of what this zinc copper Daniel cell. This cell we call it as which cell? A Daniel cell. This is a galvanic cell. The best example is zinc copper cell. Okay. So first of all, we have taken two half cells. That is first one on the left side. We have taken zinc sulfate solution and a zinc rod is dipped into that. And we have taken copper sulfate solution on the right side. And we have dipped copper electrode. Okay. Now you have to study a word. Okay, a word that is commonly known. Okay, loan. Have you heard about the word loan? Yes. Okay, loan. We went to bank to take some loan, right? Sometimes, okay, if we need money, we have to take some loan, right? So that is LOAN. That is the spelling. Okay. So this word is related to which cell? Galvanic cell. Yeah, electrochemical cell. So L stands for left. Okay, L stands for left. O stands for oxidation. Okay, O stands for oxidation. A stands for anode. And N stands for negative. So when you study these words, you will not forget the sign and what is happening to the left side. Anything we will never forget everything. Okay, so that means you will never forget anything if you study this word. Okay, so what is left? This is the left portion, right? And it is oxidation taking place and it is anode. So left side should be what? Left side should be anode. What is that? Left side should be anode. So this is what? Anode. So whenever there is anode, oxidation will be taking place at anode always. Okay, oxidation. Anode, when you hear the word anode, just think about oxidation. Okay, anode always undergo oxidation. Oxidation will be surely taking place at anode, whatever the case. But this electrode charge will be different for some. Next, we will be studying about electrolytic cells. So it will be different. So you have to study this word lon. So you'll be getting an understanding about lon. This is N. So here the anode is with charge? Negative charge. Okay, anode is negative in the case of which one? Galvanic cell. Yeah, Daniel cell. Okay. So in anode, oxidation takes place. And what is oxidation? Oxidation is, yes, it is loss of electrons. Always oxidation is what? Loss of electrons. Okay. So always remember the four words left of oxidation, anode, negative, lon. Think about the one word in your mind. Paste it in your brain. Okay, lon. Lon is related to galvanic cell. Left side always anode. It is oxidation and anode is negative electrode. Okay. Then we know oxidation is loss of electrons. So what is happening in this zinc sulfate solution? Let us see. In this zinc sulfate solution, loss of electrons take place, right? So zinc will donate its 2 electrons and will become zinc 2 plus. And electrons are donating, right? So it will become 2 electrons. Okay. Zinc is donating its 2 electrons and it will become Zn2 plus electrons. Okay. Zinc sulfate solution, Zn2 plus electrons. 2 electrons will be going like this. Okay. It will be passing. Now, what is happening this side? Now, let us move on to this side, right? What is happening in this side? Let us see what is happening to this side is that it is copper there, right? Copper. Okay. Now, let us see what is happening to the next side. So, this is anode means right will be what? Automatically cathode, right? So, this is cathode. And what will be taking place at cathode? If anode is oxidation, so automatically cathode will be a reduction. And what is reduction? Reduction is gain of electrons. Reduction is gain of electrons. Okay. And tell me, what is the charge of this cathode? Anode is negative. So cathode will be positive electrode. Okay. Just by the simple technique of Learnwizz, L-O-A-N, you will be clear about what is happening to the left side. Left side is oxidation, and oxidation takes place always at anode, and in the case of galvanic cell, anode is negative. Okay, and now tell me what will be happening at this right side. Zinc 2 plus is donating 2 electrons, right? Yes. So that 2 electrons will be gained by this copper, and it will become Cu, copper. Okay, this is the reaction taking place at cathode, and here it is taking place at anode, loss of electrons. Okay, so 2 reactions has taken place. What are the 2 reactions that has taken place? The 2 reactions are at anode, zinc donated 2 electrons and become Zn2 plus, and at cathode what happened? Cu2 plus will gain that 2 electrons and will become Cu. Okay, then how will you write the overall reaction? Overall reaction taking place in galvanic cell, over cell reaction. So what will be the overall reaction taking place in galvanic cell? Overall reaction will be 2 will cancel, right? So what is in the right side? Zn plus Cu2 plus. Then arrow mark. Then Zn2 plus plus Cu. So this is the overall reaction taking place at this galvanic cell. Which cell? Daniel cell is the best example for that. So always this is an electrochemical cell. Electrochemical cell means what? Chemical energy will be converting to electrical energy, and here there will be 2 half cells. And remember the word learn, left oxidation, anode negative. Then you can write down the left side reaction. Okay, loss of electrons is oxidation. So zinc loses its 2 electrons. That 2 electrons will be gained by this copper, and copper will become what? It will gain that 2 electrons and will become Cu. Okay, and you can write overall reactions also. Okay, now the important thing that how will you make a galvanic cell? So what you have to do? What you have to do is, it is very simple. When you are asked to find out how will you write make a galvanic cell. Okay, so you know the reactivity series, right? You are familiar with the reactivity series of metals, and if you are asked to make a galvanic cell of sodium and copper, okay, so you must think that which is more reactive here. Which is more reactive? Sodium is more reactive. We know that, right? In the reactivity series, sodium is at the top and more reactive. So copper is less reactive. So the more reactive one should be act as a anode. Okay. So you have to take it appropriate sodium solution, sodium sulfate, like the solution. You have to dip a sodium rod like that. And you have to take a copper sulfate solution and dip a copper rod in that. Okay, same solution, same rod. That is again an important point you have to notice. Okay, and the next important point is more reactive one should be acting as a anode. Okay, then only it can lose electron, right? The more reactive one is able to lose their electrons fastly, then, right? So that is the thing you have to remember. Okay, so more reactive one should be act as an anode. So yeah, it is better to place it the left side. Then oxidation should be taking place and it should be a negative electron. Okay, that is about the galvanic cell. Okay, hope you enjoyed the video. If you like the video, please share, subscribe our channel. Okay. Okay, one more thing I have to convey is that there is a U to be placed, right? Where is the where is the flow of these electrons? Okay, we have to study that also. I will show you. So here you can see a galvanic cell. Okay, a galvanic cell, and you can see a voltmeter is placed between two electrodes, right and left. Okay, and the electrons are donated by which electrode? Anode, right? Zinc. Okay, and it is a negative electrode. You can see the charge here, and electrons are flowing. Where is the flow of electron? Which direction the electrons are flowing? Okay, you have to remember the electron flow direction. Okay, you have to mark like the electron flow direction is into from left to right. Okay, and the one more thing you have to remember here is I have drawn in the picture a salt bridge, right? You have seen a salt bridge. I told you that there is a U-shaped tube, right? That is connected to the two half cells. A U-shaped tube is there. And what is the use of that U-shaped tube? That is we are going to discuss. We have a U-shaped tube that is called as salt bridge. It has several importance in that galvanic cell. It is not just sitting simply there, right? It has some importance. Salt bridge. It is a U-shaped bridge. Okay, U-shaped. And in between that there is a paste of agar agar or gelatin in KCl. Okay, and what is the use of this salt bridge? So main use is to maintain the electrical neutrality. Okay, that is the use of that salt bridge so that stability. Okay, it is the thing that is making the stability of the galvanics. Okay, and this salt bridge will prevent the diffusion of solution between two half cells. Okay, so it is the one that is completing the circuit. Okay, this one will come. So main use of this salt bridge is to maintain the electrical neutrality, and it will prevent the diffusion of the solutions of two half cells. Okay, that is the use of this salt. Okay, you have to study this because 2-mark question or 1-mark question will be coming. What is this salt bridge use? What is the right, the two uses of salt bridge? What is inside there? What is a salt bridge, like that? So you can score a 1 mark from this. And sometimes you will be given some diagrams and you will be asked to write down the reaction taking place at anode and cathode. So you know anode oxidation, right? And which is anode, which is cathode, you now know because you know the electroreactivity series, right? So you can select the anode and cathodes and you can do oxidation. Oxidation means what? Loss of electrons. Okay. So that's it. Very simple topic. Hope you enjoyed the video. If you like the video, please share our channel, subscribe our channel. Okay. Okay. See you on the next video. Till then, bye. Have a nice time. Thank you.